Hey, all you cool cats and kittens. The second part of the lesson on writing reactions and getting ready for stoichiometry are the types of reactions that are called total ionic reactions. Now, we are going to practice these. You at home, you will feel your rage rising as we practice these because they are inconvenient and they are annoying. I do not like total ionic reactions. They take a long time to do. There are some shortcuts that we'll get into, but you have to understand the theory of total ionic reactions because they will explain the next type of reactions we're going to be looking at tomorrow. Okay? Total ionic reactions show all aqueous substances as ions. Okay? All aqueous substances are going to be shown as ions. So if something's a solid, we're not going to do much with it. If something's aqueous, we are going to have to break that up. And the big thing that gets very confusing is that when we balance it, do not forget the mole ratios. So this is the second step of writing these reactions that we're going to get to called net. Now, as I said yesterday, we're almost only going to do non-ionic reactions when we get to stoichiometry, but this process is really important for Chem 30. Okay, we'll just dive right into it. Nope, not that one. Nope, that's a bad meme. Okay, here we are. Zinc metal reacts with copper 2 nitrate. We'll write down solution. Okay, so before we can get to a total, unless you get really, really, really good at these reactions, we have to start with the non-ionic reaction because it's a lot easier to balance a non-ionic reaction. Okay, so we practiced these yesterday. This is a single replacement. We've got an element mixing with a compound. Copper 2 is 2 plus. Nitrate is 1 negative. So we need 2 nitrates for every copper. Okay, it says it's a solution. All right, the copper and the zinc are going to switch. So we wind up with copper by itself. Zinc is 2 plus. And zinc with nitrate is aqueous because all aqueous compounds, if possible, are going to be aqueous. Okay. Do we need to balance this? The answer is no. It's already balanced the way that it is. This, right now, this is the non-ionic reaction. Okay. We are now going to go to the total ionic reaction. The total reaction shows all the ions busted up. And yes, we're going to do this 3 times. So you may not be annoyed right now, but I can guarantee you by the third one of these, you're going to be a little annoyed. Okay. Solids don't get broken up. Solids, gases, liquids don't get broken up. But this aqueous compound does. This compound we have to show in the total ionic compound as all of the ions separated because they actually do. Aqueous substances, we talked about this, they dissociate. So this is going to dissociate into a copper ion and 2 nitrate ions. Now, what we're doing here is exactly what we did before, where we showed how this substance breaks apart. This is really what that looks like. But we're just saying, okay, it's not actually this if it's aqueous. It's actually this when it's in solution. Okay. All right. Arrow. Okay, copper solid, leave it alone. Perfect. And then We have zinc ions, because that's aqueous. I'm going to break that up. And how many nitrates do I have? 2. 2 nitrate ions. Okay. This is the total. This is the non. This is the total. Okay. Total shows everything that's aqueous breaking up. All right, let's try another one. Barium chloride solution reacts with the sodium sulfate solution. It produces a precipitate, and a solution. Okay, before we can get to the total, we got to write out the non. The non is writing it out normally. Okay, barium is 2 plus, chloride is 1 negative. All right, so and it says it's a solution, so it's aqueous. And it reacts with sodium sulfate solution. Sodium is 1 plus, sulfate is 2 negative. Sulfate is a polyatomic. So I need 2 sulfates for every, or 2 sodiums for every sulfate. All right, this is a double replacement. So the sodium and the barium are going to switch. The barium goes over with the sulfate, and the sodium goes over with the chloride. Now, I don't know about you. If this says one of those is going to be a precipitate and the other one's going to be a solution, I'm pretty sure we can all agree that salt does dissolve. That means this one must not be. You can check your solubility table if you don't believe me, or you can just get some salt and put it in water and see if it dissolves. Now, this is not balanced. If we look over here, we have 2 chlorides and 2 sodiums, so we just got to put a 2 right there. Now, we're not done. That's the non-ionic reaction. Now we have to do this again and break up all of the ions. Yes, do you feel the annoyance? Yes, it's rising. It's getting more and more and more annoying. All right, so we have a barium ion. Barium's 2 plus. Remember, I've got to break up my aqueous compounds. Add that to 2 chloride ions. Okay, because barium, if you want to think of it this way, is like this, and I've chopped it up. I've busted it apart. So I have a barium, and then I've got 2 chloride ions. Right? That's why there's 2 chlorides. Now, there is going to be some people who are going to get confused, and they're going to write chloride as Cl2 gas. Okay? Now, that doesn't happen. When you break apart an ionic compound, you break it apart into ions. You don't break apart an ionic compound and turn the ions into a deadly gas. Okay? Doesn't happen. All right, add that to sodium ions and sulfate ions. Oh, thank goodness there's an arrow. Oh, look, it's a solid. Yes, I didn't have to break that up. Okay, and then I have sodium ions and chlorides. Now, I've made some mistakes. Can you guys spot my mistakes? What did I forget? If the answer was, I forgot to stop this lesson so you guys could just stop learning, you're wrong. I have 2 sodiums right there, so I need to put a 2 there. Also, that 2 in front of this compound doubles everything behind it. So I have 2 and 2. You should have the same number of entities on either side. So if I look here, I've got 2 chlorides. I should have 2 chlorides over there. All right, that is the total ionic compound for our reaction for this one. Remember I said we were doing 3? We are. Okay. Lead acetate solution reacts with magnesium iodide solution. Oh man, I'll go pretty quick. Okay, write out the non. Lead is 2 plus. Well, okay, is it? Well, we got to check our table. It doesn't tell us. Lead is one of those multivalent ones. It's either 2 or it's 4. The 2 charge comes first. So if you're not told, you pick the most common charge, which is lead 2. Acetate is a polyatomic ion. It's CH3COO. It's a very weird one. It's only 1 negative, so we need 2 of those. Question says we have an aqueous substance. Okay. Then we have magnesium iodide solution. Magnesium is 2 plus. All right, this is a double replacement. So the lead goes with the iodide, and the magnesium goes with the acetate. Okay. Oh, I don't know if that's aqueous. Maybe I jumped the gun right there. Now, I actually don't have this one memorized. I know lead doesn't play nice with lots of stuff. Lucky for me, I've got your data booklet. Okay, that data booklet. Lucky for me, I've got my data booklet. And in my data booklet, iodide is not soluble with lead. Look, if I had guessed, I would have got that one wrong. Okay, and acetate's pretty soluble, and it is soluble with magnesium. Okay. Now, are we balanced? We actually are. So this one balanced itself quite nicely. 2 acetates, 2 acetates, 2 iodides, 2 iodides. Okay. We have to break up everything that's aqueous. So this is going to be a bit of a pain. Okay, so we've got lead 2. All right. Now, that 2 means there's 2 acetates. 2 acetates. All right. And we got to bust up this. Oh, man. 2 iodides. Arrow. Oh, thank goodness. It's solid. Yes. Oh, man, this one's not. Magnesium 2 plus. And 2 CH3COO negative. Okay. Now, I'm going to warn everybody, once we start to do actual assessment, you're going to have questions to do in practice today, and then I'm going to introduce another one tomorrow. And tomorrow, that's when you're going to be starting your assignment. That's going to be due by the end of the week. So you will lose marks if you forget to do things like put charges in, right? You'll get a couple freebies, and then you're going to start to lose marks. If you put no states, like if you're handing in an assignment to Fluke or to Zelensky or I, or if the coronavirus never happened and you were in class, if you left all of that out, you would get nitpicked down to 0. This is a big deal from a syntax level, okay? If you forget charges and if you forget states, it's like writing a sentence like this. Let's eat grandma. Okay? You're not sure if you're a cannibal or let's eat grandma. Right? Or let's eat grandma. Maybe. Okay, anyways, you see what I mean. Whoops. Okay, so that's the lesson for today, guys. You'll have some questions to work on with the key. Remember, tomorrow we will be starting the hand-in project. You'll have a couple days to work on that.